Assalamualaikum warahmatullahi wabarakatuh and a very good day. I am Nur Shamimi binti Muhammad Salihim. I am currently a final year student of Bachelor in Science, Chemistry, Forensic Analysis. I am supervised by Dr. Muhammad Sufri bin Mastuli. Today, I would like to present my final year project with a topic, a recent catalytic deoxygenation of renewable feedstocks for biojet fuel production. The aviation industry contributes significantly to global socio-economic growth. Thus, demand for fossil fuel in the aviation sector has increased year after year and expected to increase by around 5% per year until 2030. Based on the research of European Parliamentary Research Service, direct carbon dioxide emission from the aviation sector in the European Union accounted for approximately 3% of global carbon dioxide emission in 2018. It is also expected that carbon dioxide emission from the aviation sector will be continued to rise with expected increase in air traffic by an annual average of 4.5 to 4.8% in the coming years. This could result in a 4.6 to 20.2% increase in global carbon dioxide emission from fossil fuel in mid-century. Therefore, it becomes paramount to replace the non-renewable fossil fuel with renewable alternative to reduce global concern that have emanated from their use. In this regard, the utilizations of biomass play a crucial role in the provision of the much-needed renewable energy resources that is sustainable in long run. Excellent options such as animal fats and plant oil triglyceride biomass due to the fact that they have a relatively simpler when compared to lignocellulose biomass. In addition, they also have lower oxygen ratio to the combustible carbon and hydrogen atoms per molecule of triglyceride. The study therefore also addresses environmental concerns that arise as a result of disposal of waste fat mineral from plant and animal processing facilities. The production of biojet fuel via catalytic deoxygenation reaction has been proposed since the reaction process under H2-free atmosphere. Renewable biojet fuel is an alternative aviation fuel manufactured by animals and plants rather than fossil fuels. Renewable biojet fuel has a greater satiety rating and straight-chain alkenes ranging from C9 to C18. In research of anthracene, renewable biojet fuel would reduce life cycle gas emission by 15 to 80% when compared to normal aviation fuel. Renewable biojet fuel, which is manufactured from waste oil products such as used oil and animal oil, provide the most environmental advantages, followed by indigenous agriculture goods such as canola oil. Renewable biojet fuel derived from oil may not be environmentally beneficial. The efficacy of deoxygenation performance for the production of biojet fuel comes from a variety of feedstock. There are few feedstocks such as triglyceride-derived oil, non-edible oil, and edible oil. Triglyceride-derived oil contains paraffin ranging from C8 to C24, with the majority of the hydrocarbon chain being C16 and C18, and be easily converted into jet fuel without the use of an energy-intensive process. The major fatty acids in triglyceride-based oil are oleic acid, palmitic acid, stearic acid, and linoleic acid. There are also minor fatty acid in triglyceride-based oil. Non-edible feedstock typically have high free fatty acid level, necessitating a pre-treatment production process. There are also some examples of edible oil such as canola oil, sunflower oil, palm oil, and soybean oil. Catalytic deoxygenation is a process of oxygen removal via heterogeneous catalyst, where it is a strategy for converting bio-oils into fuels. Catalysts and reactants are in different phases or multiphases in a heterogeneous state, such as solid, liquid, and gas. Catalysts are classified into several types based on their chemical properties and the types of reactants they catalyze. Noble metal, sulfide, and non-sulfide catalysts are the three most common types of catalysts used in the oxygenation reaction of triglyceride and model compounds. According to a study, the most active metal catalyst deoxygenation reaction were those loaded with noble metal, such as palladium, platinum, and ruthenium. Despite that the noble-based catalysts demonstrate high selectivity for oxygen removal during hydrocarbon formation, the high cost and scarcity of noble metals limit large-scale biojet fuel production. Sulfide catalyst has been discovered to be highly active and selective for the conversion of triglyceride feedstock. However, there are some disadvantages associated with sulfide catalysts, which are responsible for final product sulfur contamination and corrosion problem because sulfide catalysts cause sulfidation in the active site of the catalyst surface. In conclusion, the nature of the vegetable oil used as feedstock is critical, and when it comes to higher alkane formation during the oxygenation reaction, saturated feedstock outperform unsaturated feedstock. Next, noble metals such as palladium and platinum with carbon support were discovered to be suitable catalysts in decarboxylation and decarbonylation reaction. Last but not least, an excellent deoxygenation catalyst should have the following characteristics such as high resistance to choke, poison, water, and other raw materials impurities, excellent deoxygenation reaction, inexpensive and abundant active compound.